We're going to continue on with our operations on polynomials unit, and we are going to multiply more polynomials. And specifically today, we're multiplying two binomials. Remember, binomial means two terms. And I'm going to show you two methods with the same problem here. And honestly, you can choose whichever method you want. The first one you'll see me do often. This is what I grew up learning to do. We're going to distribute. So I'm going to do x times 3x and x times negative 4. Okay, so I get 3x squared minus 4x. I also need to do 2 times 3x and 2 times negative 4. And that 2 is positive. There's a plus sign in front of it. So 2 times 3x is 6x, and 2 times negative 4 is negative 8. Now, most common mistakes here are signs, and then also with your exponents. Notice x times x is x squared, but I don't need to worry about changing my exponents other than that. So I have like terms here. I'm going to combine those two together to get a final answer of 3x squared, and then negative 4 and 6 is positive 2x minus 8. Notice those x's didn't change my exponent when I added them. It only changed them in the first step when I multiplied them. Let's see if I can create a table here. For the other method, let's see if I can insert a table. I'm going to create a table here. Make it a little bit bigger. Oh my goodness. Okay. And we're going to move this. Okay, so box method here is a lot like a Punnett square in biology. It actually doesn't matter how you set it up, you just need to keep it together. So my first binomial here is x plus 2. Okay, I'm going to write x plus 2 across the top. My second binomial is 3x minus 4. So I'm going to write 3x minus 4 on the side. What I'm going to do is I'm going to fill this in by multiplying. So I'm going to do 3x times x, which is 3x squared, and 3x times 2, which is 6x. Across the bottom row, I'm going to do negative 4 times x, which is negative 4x, and negative 4 times 2, which is negative 8. Your final step then is to go ahead and combine your like terms, which are typically diagonal from each other. So if I combine my like terms there, remember when I add or subtract, it does not change the exponent. I have 3x squared, and then negative 4x and 6x give me a positive 2x, and then my negative 8 comes down. Okay, two different approaches to get the same answer. Completely up to you. When I do the examples, I'm going to mix them up and do each one a couple times. Okay, so we have 4 problems here. I'll do my distributing method first, and then I'll do the box method second. So when I distribute, I'm going to do x times x and x times negative 2. Okay, so I like to write it like that so you can see that. And then I'm also going to do 6 times x and 6 times negative 2. And that 6 is positive. Okay, so going back, x times x is x squared. X times negative 2 is negative 2x. And then 6 times x is 6x, and 6 times negative 2 is negative 12. Go ahead and combine your like terms. Typically, those middle two are your like terms. Do not change your exponent. And remember that negative 2 and 6 gives me a positive 4. Bring down my x squared, bring down my negative 12, and I'm good. I'm going to do that method one more time just so you can see it, and then I'll go ahead and do the box method. We're going to start by taking that 3x and multiplying it by x plus 4. Okay, so that's this part here. And then we're going to go ahead and take my 1 and multiply by x plus 4, and that's a positive 1, and distribute. So let's go ahead and simplify this. So 3x times x is 3x squared. 3x times 4 is 12x. 1 times x is 1x. You don't really need to write the 1 there, but it's fine. And then 1 times 4 is 4. Notice our like terms here are 12x and 1x. 12 plus 1 gives me 13. And we're good from there. I'm going to go ahead and insert two tables here. See if we can make it fit better. Copy that and paste it next to the other one, and we'll use these tables. Okay, let's see where we're at here. Using a table. I'm going to show you to write it the same way I did on the last one. So my first binomial is x minus 3, so that's going to go across the top. My second binomial is 2x minus 5, so that's going to go down the side. I'm going to go ahead and multiply to fill these in. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 5 times x is negative 5x. And negative 5 times negative 3 is a positive 15. Okay, combine these two together. So negative 5 and negative 6 give me negative 11. So I have 2x squared, negative 11x, and a positive 15. Okay, next one, same thing. I'm going to show you that this doesn't matter. So I'm going to do this down the side first, and I'm going to do this one across the top. So I have 5x plus 1. And I'm going to go ahead and fill that in. So x times 5x is 5x squared. X times 1 is 1x. Negative 6 times 5x is negative 30x. And negative 6 times 1 is negative 6. We're going to go ahead and combine our like terms like we did in the last ones. So if I combine those two together, I end up with, I'll write this over here, 5x squared. You owe me $30 and you pay me 1, you still owe me 29, so negative 29x, and then minus 6. Okay, so I have answer here, answer here, answer here, answer here. Only thing I want to show you is if you use the other method for this, be really careful, because that is a minus 6, so when you're distributing, make sure you pay attention to that negative sign. Okay, so that's if you're using this method. All right, go ahead and try those practice problems, and actually check that. We're going to go ahead and do special cases. If you see this twice squared, that means you're writing it twice. So 2x minus 3 times 2x minus 3. So I'm going to go ahead and write this out using the distributive property. And we're going to multiply. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is a positive 9. Let's go ahead and combine our like terms there. So negative 6 and negative 6 gives me a negative 12. So I have 4x squared minus 12x plus 9. Again, when I am adding and subtracting terms, I do not change my exponents. Okay, so then we're going to do the same thing for this next one. If we're squaring something, it's the same thing as writing it twice. So if I set up my box, y plus 5 and y plus 5, y times y is y squared. 5 times y is 5y. 5 times y is 5y, and 5 times 5 is 25. We're going to go ahead and combine our like terms together. 5y plus 5y gives us 10y. So we have a y squared plus 10y plus 25. One other one, these are conjugate binomials. The reason they're called conjugates is because they're almost identical. The only difference is that sign there. So if I set this one up using the distributive property, okay, x came down here, 1 came down there, and then the second group stayed the same. Distribute, x times x is x squared, x times -1 is -1x. For the second group, 1 times x is 1x, and 1 times -1 is -1. Be really careful with your signs here. But what should always happen when you have conjugate binomials, meaning they're almost identical other than the signs, is when you go to combine like terms, that middle term is going to cancel out. So I end up with x squared minus 1 there. Okay, if we use the box method, same idea. 2y plus 7, 2y minus 7. 2 times 2 is 4, and then I have a y squared. 2 times 7 is 14 with my y. So -7 times 2y is -14y, and -7 times 7 is -49. Notice when I go to combine my like terms here, these two cancel each other out. So I'm left with 4y squared minus 49. Okay, so that happens whenever they're conjugate binomials. Okay, you try it. There's 4 problems here. Come back and check your answer. So hit pause while you do it, and then come back and see how you're doing. Okay, I didn't show the steps there, but the answers are there. So go ahead and check your work. If you have any questions, jump into the Google Meet and let me know, or hit that help button and empower, and that'll let me know that you need help. Otherwise, go ahead and do the practice that is in your packet and check your answers when you're done. Have a great day.